Thanks guys, we'll get back into it. Thank you guys, we'll get back into it. Okay, so the smaller roots. Root, remember, is one of these words. Thank you. That means solution. Okay, or the value that gives the answer that you're after, or the value that gives you 0. There's lots of ways of describing the idea of a root. So it tells you there's this equation. It's got a missing value in it, and we should be able to use the information from the problem to figure out what that missing value is. So it says find the other root of the equation and the value of c. I'm actually going to do it in the other order. It works better if you do it in the other order. If you find the value of c first and then you find the other roots. Basically what I know is that that's a quadratic equation, and quadratic equations normally can be written like this. And if I know one of these brackets, I know one of the solutions. So I'm going to work that backwards. I know one of the solutions, so I probably know what one of the brackets is. Minus 4 means that one of the brackets is going to be x plus 4. Okay, or a multiple of that. It could be 2x plus 8 or something like that. But that doesn't really work with the numbers that I've got. So I'm going to go with that and see if I need to change anything. So pretty much what I'm asking myself is, what's the other bracket? To get the 3x squared part, what would have to be in the front of here? Yeah, that would work. So I'll multiply out what I've got so far. I'll multiply out what I've got so far. 3x times x is 3x squared. Is I, please? I've got 3x times 4, that gives me 12x. And that's about all I can do so far, 12x. Now the x value I'm trying to get is 5x. So how would I get 12x back down to being 5x? I'd subtract 7x's away from it, right? So what number can I choose here that's going to allow me to take away 7x's? It's going to, yeah, minus 7, because it has to be multiplied by this term, and those are going to combine to give me this. Alright? So that works, and now I've done that times that, I've done that times that, and I've done that times that. The only multiplication I haven't done yet is, I'm lost now, the 4 times the 3x, which, no, I've done that. The 7 times the 4, sorry, the last in each bracket, apologies. So negative 7 times 4 gives me negative 28. Okay, so have I answered the question? Kinda, but not really. What's my c value? Yep, that's the number part of the equation. So I can state that c is equal to negative 28. And it also asks me for the other root, or the other solution to the equation. And that's going to be related to the other bracket that we've just created. So 3x minus 7, how do we make that equal 0? So I'm trying to make that bracket equal 0. Yeah, so normally you would just take the opposite of that number, but because there's a 3 there, it's a bit more complicated. So I'm going to move the 7 to the other side, gives me positive 7. 3x is equal to positive 7, therefore x must be equal to 7 over 3. Okay? And that's the way they expect the answer. They didn't really expect a decimal value for this. So we've got the solution, we've got the c value, we've solved the problem. Sorry, I can't be sure about this, but I think this was a merit question. Oh, I do have the answers there. Good. No, it was an excellence question. Okay, so opportunity to get a decent amount of points from that. Okay, on to our last question. Didn't go that well. I was a little bit surprised, but that's okay. The perimeter of a rectangle playing field is 170 meters, so it's worthwhile drawing a diagram, so at least you can start noting down things as you see them. So 170 meters is the perimeter. That means that this side plus this side plus this side plus this side adds up to 170. The other information I've got is that the diagonal length of the field is 65 meters. Okay, so something like that, 65 meters. At this point, I'm starting to see this looks like a Pythagoras' theorem problem, right-angled triangles. Okay. So while we haven't learned Pythagoras this year, it's expected that when you're in year 11 you did, so that you should be able to apply it here. I don't know what either of these sides are, but what I do know is that they will add up to a certain amount. Okay? If the whole perimeter is 170 meters, the perimeter is given by, if I call this x and I call this y, perimeter is given by 2x plus 2y, adding up the four sides together. You right with that? Mm-hmm. So that must be equal to 170. Okay, so there's an equation that's got some stuff involved in it. Is there another equation I can write using the 65 meters somehow? Exactly. People listening to this on the video can't hear everyone shouting out Pythagoras' theorem, sir. So we're going to go x squared plus y squared is equal to 65 squared, hypotenuse squared. Okay? And this is actually really related to the stuff we're working on at the moment. This is simultaneous equations, two equations using two different letters, and we're trying to find the answer to both at the same time. So what methods did we learn? Elimination or substitution. And I kind of made the statement a couple lessons ago that substitution is better when you're dealing with more complicated equations, all right, rather than just two linear ones. So to do substitution, we need to rearrange one of these equations to make either x the subject or y the subject. And it works just as well whichever way you do it. So I'm going to make x the subject. So I'm going to move the 2y to the other side. So 2x is equal to 170 minus 2y. And then I'm going to half everything. So x, half of 170 is 85. Half of negative 2y is negative y. Okay, so that's my equation that I'm going to substitute. I'm going to put it in there. Alright, so I've got 85 minus y, so that's what x squared looks like now, plus y squared, because that's a y, I'm not substituting, and 65 is just 65. I might as well turn that into a number. 65 squared is 4225. Alright, so I should be able to do everything I want with this equation now, which means I just need to do some algebra and see where I get to. So I've got to expand this bracket, 85 minus y times 85 minus y. It's going to give me 85 squared, so 7225. I'm going to have 85 times negative y, and then I'm going to have it in the other bracket as well, well, the combinations. So I'm going to have two lots of 85 times negative y, alright, which is negative 170y. And I'm also going to get negative y times negative y. And there's a chance for a mistake. Some people would write negative y squared, but two negatives multiplied together, remember, give you positive y squared. So that's, you could show more steps if you wanted to. That is the expanded version of 85 minus y squared. Okay, and I've got the plus y squared, which I haven't written in yet. I've got the equals I haven't written yet, and I've got the 4225. Okay, next step, I can see there's some like terms to work with. Y squared and y squared gives me, and I'm going to put this at the front now. Y squared and y squared is 2y squared. And then I'm going to put my middle term next, which is negative 170y. And because I'm running out of space, normally I would write plus 7225 is equal to 4225, but I'm going to subtract that 4225 away at the same time. Alright, so 7225 minus 4225 gives me 3000. So I end up with a plus 3000 is equal to 0. Alright, now partly because I'm lazy and partly because I'm running out of space, I'm going to resort to the graphics calculator to solve that equation. So that's in equation mode. Poly, degree 2, type in the numbers. Even though it's not x's, same deal as y's. So it's a 2, it's a minus 170, and it's a 3000. Okay. Tells me that the answers are actually quite nice. Either y, notice my calculator says x, but I'm writing y is equal to 60 meters, or y is equal to 25 meters. So I could go back through and figure out what x value this results in, and same with this, by looking at that equation there. But it often happens this way, that if I chose the y value, substituting 60 into here gives me the answer of x is equal to 25 meters. If I chose to use the 25, 85 take away 25, I get the x value is equal to 60. They're kind of, you can sort of see that they're the opposites of the numbers that were given to me on the calculator anyway. Alright, so the answer to this is the rectangle is either 25 meters wide and 60 meters tall, or it's 25 meters tall and 60 meters wide. Okay, and that makes sense, because if you rotate the rectangle around, you've still got the same numbers involved, they're just in different directions. Okay, and that was, of course, an excellence question. Alright, so I'll stop that. We can ask some more questions about this if you want.